and welcome to today's lesson, which is on finding the equation of a straight line. Now, first of all, I want to take us over to Desmos, which is the graphing website, to have a look at what happens when we change some of the variables on a straight line. So you'll notice here that I've got an equation which is in the form y equals mx plus c. Okay, and we just want to see what happens as some of these changes. So the first thing I'm going to change is this m over here. So I'm just going to increase this m. I want us to see what happens as it increases. So as this increases, the line actually gets steeper, and that's because this m represents the gradient. If you saw the last video on gradient, the gradient is the steepness of the line. So as m increases, this line actually gets steeper, and obviously it gets steeper and steeper and steeper. And then as we come back down from m, we notice that it hits 0, okay? And at 0, if I can hit it, where is it? There we go. It's 0. At 0, we have no gradient, which means that the line is flat, okay? So then what we're looking at is a negative gradient, which is when it's going down. So here, we've got a negative gradient, so it's minus 1.1. So that means this gradient is going down here, okay? It's going the other way. And obviously, as we get bigger with that, the bigger the negative gradient, so minus 4, minus 5, the steeper this is as well, going the other way. So let's go back to 1 here, a gradient of 1. So next thing I want to see is what happens when we change this c. So let's increase the c at the moment and see what happens now. As I increase this c, you'll notice it looks as if the line moves up, and it does. Okay, when I change this c, what's happening is you'll notice here that if I change this to 4, we're actually cutting the y-axis at 4, which is there. And as I come down, if I change that to 2.8, we're actually cutting at 2.8. If I move it to a negative value, that means I'm actually cutting at minus 4. So this c value is called the y-intercept, and m, which is in front of it, is called the gradient. Okay, so that's a little introduction into some of these questions. So let's have a look at our first question. In fact, just before that, it's probably worth noting, to get it down in your notes, that the equation of the line always comes in the form y equals mx plus c. Okay? Now we've just seen from this that m in this is the gradient, so the steepness of the line, okay? And c is where you're cutting the y-intercept. Okay? Now where I'm cutting the y-intercept, when I'm cutting the y-intercept, it means that I'm not going across at all. Now you might think that y must be equal to 0 in this case, but that's not actually the case. We cut the y-intercept. If I have a look at this graph here, and this is x and this is y, I actually cut here when my x is equal to 0. So I cut it when it's at 0 and something. I'm going to call that c, okay? So here, m is my gradient, and this is the steepness of the line, how steep it is. And if you've got something which is 0c, so a point which is 0c, this is the y-intercept, so where I'm cutting that y-axis. Okay, so let's have a look at this first question. I'm going to make it big so you can see it. So the first one, a line has a gradient of 3 and passes through the point 0, 2. What is the equation of this line? So going back to this, we know that my gradient here is 3, so the steepness is 3, and it actually tells you, notice it's 0, 2, so it actually tells you where it's cutting the y-axis. So if I was to draw this one, my gradient, which is from that triangle here, is 3, and where I'm cutting the y-axis is 0, 2. So in which case, we know that this value here is our c, this value here is our m, so the equation of this line, for example 1, with a gradient of 3, an intercept of 0, 2, would be y equals 3x plus 2, where 3 is the gradient and 2 is that y-intercept. So nice little easy one to start us off there. So pause now and have a little go at that one on the right hand side. I think you'll find that one quite easy as well. Okay, so let's have a look at this one together. Again, I do think this one's pretty easy because it gives you the gradient and it gives you the y-intercept. That's not always going to be the case. So with this one here, it says the line has a gradient of -1 and passes through 0, 3. What is the equation of the line? Well, we know it's in the form y equals mx plus c, and it's always worth writing this down. So y is equal to, the gradient is -1x, but I'm not going to write -1. I'm just going to write -x plus 3 in this case, because the c is 3. Now you could put -1 in there, but we know that we don't put a negative in front of a letter. Sorry, we don't put a -1 in front of a letter, we just put minus. So this is y is equal to -x plus 3. So let's have a look at our next question. So just check those answers. So 3x plus 2 and -x plus 3, super, brilliant. So give an equation for this line. Now, this one here is a little bit trickier because we've actually got the line. It's especially tricky for us doing it online because we've got to really see what's happening with this one. So remember, with this, we need two things. We need the gradient and the intercept. So this is the important part. We need to find the gradient in some way, and we also need to find where it's crossing the y-axis. Now, crossing the y-axis is actually quite easy in this because I can see that it's crossing it -1. So that's quite easy, but it's the gradient which is a little bit harder. But hopefully you've watched a video on gradient before this. If you haven't, then have a look at the link and watch that video first. But the gradient, when I'm doing this, is all about picking 2 points and then drawing a triangle. So in this case, I'm going to pick this one here, which is 0, -1. I'm going to pick one further up, which is going to be 2, 3. So 2, 3. It doesn't matter which point you pick. So 2, 3. And then the key part to this is about drawing that right angle triangle. So drawing a right angle triangle there. Now to find the gradient, we know that it's m is equal to the change in y over the change in x. And in this case, the change in y is how high it is. So you might want to put a dotted line there just to see that. Because from here to here, it's going to be from -1 to 3. From here to here is 3. From here to here is 1, because I'm going down to -1. So the total height of this is 4. And then across here, so from, do it in a red pen so we can see it, from 0 over to 2, well, that's just going to be a cross by 2. So in which case my gradient, m, is equal to 4 over 2. So m is equal to 2, like so. Brilliant. Super. So we've got our gradient. We can see what our intercept is. Our intercept is actually -1. So then we can say what the equation of the line is. It's y equals mx plus c. It's always worth writing that down. So y is equal to 2x plus, well, it's crossing our y-axis at -1. We can see that there, okay, right there. So 2x, I've put plus, it should be negative, sorry. 2x minus 1, brilliant. Okay, so I'll make this one on the right big for you. It's probably worth drawing out a little sketch like I have. So pause now and have a little go at that one on the right-hand side. Okay, so let's go through this one together then. So again, it's about picking 2 points, okay? So this one here is example 4. Remember to make sure you're getting these down in your notes. Remember, the only way to learn maths is to do it. So I picked 2 points on this graph. It's coming down like so. I'm just going to pick the ones that cross. So 0, 2, which is there. And I'll pick this one here, which is 4, 0, because that makes life easier for us. First of all, we've noticed that it's going down, so I know it's going to be a negative gradient. So let's think about how far it's going down. Well, if this is 2 and this is 0, remember it's the y here. So I'm going down by 2, down from 2 to 0. And then how far am I going to cross? Well, I'm going to cross from 0 to 4. So from 0 to 4 is 4. So in which case, my gradient, m, is equal to the change in y over the change in x. So m is equal to the change in y, which in this case is negative 2 over 4. I will simplify that. What goes into negative 2 and 4? Well, 2 goes into both of them. 2 goes into 2 once, so minus 1. 2 goes into 2. 2 goes into 4 twice, so negative 1 over 2. So my gradient is a negative half. So the next thing I need to see is where I'm crossing the y-axis. So I'm crossing the y-axis in this one at this point here, which is 2. So it's y equals mx plus c. So y is equal to a negative half x plus 2, like so. Brilliant. Okay, let's check those answers. 2x minus 1 and a half x plus 2. Absolutely fantastic. Okay, so let's have a look at these next two questions then. So find the equation of the line that has a gradient of 2 and passes through 2, 5. So with this one here, the first thing that we notice is that it's not 0 something. Remember, the y-intercept crosses it like 0, 4, 0, 5. This is actually 2, 5. So this is actually quite tricky now. Now what we've got to do with this is we've got to use substitution and rearranging to actually find out what that C value is. You've already got the gradients, that's brilliant, but you have got to use the coordinate to find out what that C value is. And this does get a little bit trickier, okay? So this one here is example 5. So when you are trying to find the equation of a line, you always need two things, okay? The gradient and any point, okay? So my gradient in this case we know is 2, so straight away I can say that m is equal to 2. And my coordinate in this case is equal to 2, 5. Now remember with that, this is x and y. These are actual values on my line, okay? So with this, there's loads of different values of x and y. It could be, well, I don't know on this line, but there are an infinite amount of values on this, of x and y on this line. But there's only one gradient and there's only one intercept, so there's one c, okay? So this could be anything on that line, and we'll be able to work out the c from there. So we always write down y equals mx plus c. We substitute in now everything we know for this equation. So we know that the gradient is 2, so we know that m is 2, and we have our value. So we have an x2, x is equal to 2, and y is equal to 5, so we can actually sub those values in. So y is equal to 5, so let's put that there, is equal to m, which is 2, times by x, which is 2, plus c. So just to make that really clear. So y is equal to 5, m is equal to 2, and this x value is 2. So I'm subbing all of that in, and then I'm going to multiply this and then solve to find c. So 5 is equal to 2 times 2, which is 4, plus c. And then I'm subtracting 4, so I end up with 1 is equal to c. Now I still haven't finished here. I found out what c is, but it's asking me for what the equation of the line is. So my equation of the line, I know comes in the format like this: y equals mx plus c, and m is 2, and c I now know is 1. So y is equal to 2x plus 1, like so. Brilliant. Super. So there's a bit of substitution here, there's a bit of rearranging, there's a lot more going on with this question. So I'll make this right-hand side one big. So pause now and have a little go at that one on the right-hand side. So pause now and have a go at that. Okay, so let's go through this together then. So this one on the right-hand side is example 6. Gradually getting harder. So notice with this one, we've got the gradient, we've got our point, but we don't have the y-intercept. So that's what I've got to find. I've got to find out what c is. So my gradient m is equal to 3. My point is equal to 4, 7, which is my x and y points. Okay, a coordinate on there. I know that the equation of a line is y equals mx plus c. So I sub in all the values. So y is 7 in this case, is equal to m, which is 3, times by x, which is 4, plus c. So 7 is equal to 3 times 4, which is 12, plus c. So then I need to find c, I need to get rid of that 12 by minusing 12, minusing 12. 7 take away 12 is equal to negative 5. That obviously just leaves you with c. So I've got c is equal to minus 5, but that's not the end. I'm asked for the equation of the line. So y equals mx plus c. So y is equal to 3x subtract 5, because c is negative 5. Super. And that's my equation of a line. So let's just check those answers. So y is equal to 2x plus 1, and y is equal to 3x minus 5. Absolutely brilliant. Super. So, okay, let's move on. Let's make it a little bit trickier. So we've had a look at quite simple ones with our gradient. We're going to have a look now at where the gradient is a little bit harder. If you're feeling confident, potentially pause now and have a little go at these yourself. I'll make them big in case you want to have a go at both of these yourself. Okay, so let's have a look at these two together. So this is example 7. In this one, we've got a gradient of negative 2, so m is equal to negative 2. We've got a point which is 4, 3. So x and y there. I know that the equation of the line is y equals mx plus c. Okay, so let's sub everything in. Y is 3 in this case. M is negative 2 and x is 4 plus the c, which I don't know. Then I multiply those two, so 3 is equal to negative 8 plus c. And then take the 8 over to the side, so plus 8 plus 8. So 3 plus 8 is 11. Add 8 to the right-hand side, I'm just left with c. Remember, I've not finished there. I've got to write it in the equation of line, so y equals mx plus c, where m in this case is equal to negative 2, and c is equal to 11. Now, plus 11. Now remember, you can sub any points into there. So if I was to sub 4, 3 into there, if I was to sub 4 into there, I would get a y value of 3. There are an infinite amount of points on this. Okay, so if you haven't already had a go at that one on the right hand side, maybe pause now and have a little go at that one on the right. So this one here is example 8. I think we should be kind of getting there now. So in this one, my gradient is equal to 1/2. My point is equal to 4, 3. So 4, 3, x, y, like so. So I have the equation of the line, which is y equals mx plus c. Subbing everything I know to work out what that c value is. So in this case, y is 3 is equal to m, which is 1/2 in this one, times by x, which is 4, plus c. Multiply this one here, so 3 is equal to 1/2 of 4, which is 2, plus c. Take away that 2, take away that 2 to find out what c is. If I take away 2 from the left-hand side, I'm left with 1. If I take away 2 from the right-hand side, I'm just left with c. So I have c is equal to 1. Remember, I've not finished there. I've still got to write it in the equation of the line, which is y equals mx plus c. So y is equal to, my gradient is 1/2. So 1/2 of x plus 1 in this case. Absolutely super. So let's just check those answers. So minus 2 plus 11 and 1/2 x plus 1. Absolutely super. So let's have a look at these next ones here. We are really getting here now. So notice with this one, determine the equation of the line that passes through 1, 3 and 4, 10, giving your answer in ax plus by is equal to c, where a, b and c are all integers and a is positive. Now, the first thing you notice with this is that you don't have a gradient, okay? But you know from the from the video when we're finding the gradient, we can find the gradient from 2 points if we draw it and draw a right angle triangle. So that's what we need to do. Okay, so this one here is example 9. Brilliant. So let's draw this out. Now they're all in the positive quadrant, so I can just draw this top one like so. 1, 3 is going to be there, so 1, 3, which is like this. And then 4, 10, so 4 across, 10 up is going to be over here. 4, 10. Remember, we're finding the gradient of the line, which is going to be this one, like so. Brilliant. So when we're finding the gradient, we draw a right angled triangle, because we know the gradient is the change in y over the change in x. We can draw our lines on if we want. So it's going to be from 3 to 10. So 3 is across here. 10 is across here like so. So how far is it between 3 and 10? Well, from 3 to 10 is 7 up, isn't it? Super. Okay. So then how far across is this? Well, it's from 1 to 4. Nice and easy. It's going to be a distance of 3 there across. So the gradient m is equal to the change in y over the change in x. So m is equal to the change in y, which in this case is 7, over the change in x, which in this case is 3. So my gradient is 7 over 3, which doesn't actually simplify. Super. Brilliant. Now I've got my gradient. I still don't know what my y-intercept is in this. So I've then got to find out my y-intercept. Now this is starting to get a little bit trickier, isn't it? So I know that my equation of the line is y equals mx plus c. Now it doesn't matter which point you pick. You can either pick the 1, 3 or the 4, 10. Both of them will give you your equation of the line because it will simplify down later on. I'm going to pick the smaller one just because it looks a little bit easier. So let's just make it really clear now what I'm using. Okay. So I know that my gradient m is equal to 7 over 3. I know that my point is 1, 3. Okay. So this is x and y. I'm subbing into y equals mx plus c like so. Okay. So y in this case is 3, is equal to m, which is 7 over 3, times by x, which is 1, plus c. Now, don't let that 7 over 3 scare you because it's a fraction, okay? Fractions are trickier, but if you're potentially using a calculator or if you write this as with 3 as the denominator, this is just exactly the same. It's still just a number. So 1 times by 7 over 3 is just 7 over 3. So I end up with 3 is equal to 7 over 3 plus x, because that times by 7 over 3 times by 1 is 7 over 3. I then need to subtract the 7 over 3 from both sides, exactly the same as you did before. I'll do the right-hand side first. If I subtract 7 over 3 from 7 over 3, I'm just left with c on that side, aren't I? Okay. Now 3 take away 7 over c. Now you can either do that on your calculator if it's a calculator paper. So 3 subtract, okay, exactly the same as I would normally, fraction 7 over 3, which in this case is equal to 2 over 3. Or you could have, if you wanted to, write 3 as a 3 with a denominator of 3. So 3 is with a denominator of 3 is going to be 9 over 3. 9 over 3 take away 7 over 3, again, is 2 over 3. Now remember that with this one, we still haven't finished, okay? This here is just the c value. But we've got our gradient, which is 7 over 3. We now have our c, so we need to write it in the equation of the line. So this is where it gets a little bit different in this question, because it asks for it in a particular format. So we know that m is equal to 7 over 3. We know that c is equal to 2 over 3. Okay? We know that the equation of the line is y equals mx plus c. And we know the gradient is there, so y is equal to 7 over 3x plus 2 over 3. Okay, now this is the equation of the line. That's fine. If it didn't say this last part, you'd leave it like that. However, the problem is they want it in the format ax plus by plus, is equal to c. Basically, they don't want that fraction in there. So to do that, we notice that the fraction is a 3. So the denominator is 3. So to get rid of that 3 as a denominator, we're timesing both sides by 3 to get rid of it. So times by 3 times by 3. If I times the left-hand side by 3, I end up with 3y is equal to 7 over 3x times by 3 is just 7x. 2 over 3 times by 3 is just 2. I've still not finished because it says it wants x to be positive, the coefficient of x to be positive, and it wants ax plus by is equal to c. So I'm going to take the 3y over and bring the 2 back. So if I take the 2 over to this side, I'm left with minus 2 on this side. If I take the 3y over, I'm going to have 7x, that stays where it is, minus 3y. I've taken the 2 over to this side, so subtracted 2 from both sides, and I've added 3 to the other side, subtracted 3y from both sides to get 3y on this side. Now, I need to just flip these around, so 7x minus 3y is equal to negative 2. I've just rearranged that, okay? And then it's in the format, which is exactly what I want. So ax plus by is equal to c, where a is positive in this case. Super. So that last part there is a little bit tricky. The only tricky part really is we know to get to this a, that's fine. We times by the 3 to get rid of the denominator, that's okay. And then we're moving these across. Just to make it really clear, if you're stuck on this bit, because I can imagine that some people are getting stuck on this bit. The way I've done this is I want x to be positive, so I need it to stay on that side. But I want the y on the same side as it. So I've minus 3y and minus 3y from both sides, just to be really clear. So on this left-hand side, I've got 0 is equal to, because they are going to cancel, 7x plus 2 minus 3y. I don't want this 2 on this side, so I'm minusing 2 from this side. That will cancel, so I'm just left with minus 2 is equal to 7x minus 3y like there. So just to confirm that part, because that is tricky, that bit. So pause now and have a little go at that question on the right-hand side. So pause now and have a go at that. Okay, so let's have a look at this one on the right together then. So again, we've got 2 points, so I know I need to find my gradient, so I'm going to have to draw my graph. It's going to be 1, negative 3, and 3, minus 2. So everything is on the right and down, so I need to draw a graph or a sketch of a graph, which looks a bit like this. So 1, negative 3, so 1 across, minus 3 down. So 1 comma negative 3, which is there. And then 3, negative 2. Actually, negative 2 is higher than negative 3. So 3 across, negative 2, I'll say is there. So 3, comma, negative 2. So 3 across, but only negative 2 down. So naturally not as far down as this one. Remember, when I'm finding my gradient, I'm finding the gradient of the line, not of the points, okay? So it's the gradient of that line. And to do that, I'm going to need to draw the right-angled triangle, which is like this, like so. Because the gradient, m, is equal to the change in y over the change in x. So I need to see how high this is and how far across. So let's deal with the y's first. Well, notice here, I'm going from negative 3 up to 2. I'm going up there. So I'm only going up by 1, aren't I? Okay, that's fine. And then how far am I going across? Well, I'm going from 1 to 3. Okay, so from 1 to 3 is going to be 2 across. So when I do this, m is equal to the change in y, which is 1, over the change in x, which is 2. So I've actually got a gradient of a half for this one. Okay, still nowhere near finished with this, because that's just the gradient. I then need to find out my c value, and I do that by subbing into y equals mx plus c. Actually, with that, the first thing I'd probably do is write down what point and what gradient I'm using. So my gradient I know is a half. I'm going to pick this one here because what times by 1 is usually easier. So my point I'm going to pick is 1, 3. You could, if you want, pick that. And if you want to test that out, maybe do pick that. See whether you get the same answer as me at the end. So this is x and y. And I'm subbing into y equals mx plus c. So y in this case is -3 is equal to a half times by 1, nice, plus c. So -3 is equal to a half times by 1, which is going to be a half plus c. So I'm going to subtract that half, so minus a half from both sides. -3, take away a half. Now, just again, you can use your calculator on this. So you go -3, subtract 1 over 2, which in this case is equal to 10 over 3. Oops. 1 over 2, sorry. That makes sense. 7 over 2. Brilliant. Okay. Or we could write the -3 as a fraction of 2. So -3 is going to be -6 over 2. Take away 1 over 2 is going to be -7 over 2 is equal to c. Now, we still haven't finished it. We're still quite a long way off, remember. Because we've got c, which is this value, -7 over 2. We've got m, which is a half. But we still need to find out, we still need to create the equation of line, but we also need to write it in the format that they want it. So, our gradient m is equal to a half, and c is equal to -7 over 2. So we know that we're subbing into the equation of line, which is y equals mx plus c. So y is equal to a half of x, subtract 7 over 2, like so. Remember, the whole point of this is I don't want that fraction. So to get rid of that, I'm timesing both sides by 2, like so. If I times the left-hand side by 2, I end up with 2y. If I times a half x by 2, I'm just left with x. If I times by -7 over 2, I'm just left with -7, like so. It wants a to be positive, so I want to keep x on this side. So -2y, -2y. If I subtract 2y from this side, I'm just left with 0. So 0 is equal to x -7 minus 2y. Add the 7, so get rid of that. 7 is equal to x minus 2y, like so. And then it wants it in the other way around, so x minus 2y is equal to 7. Tricky little part that at the end, but now we've got it in the terms of ax plus by is equal to c. Don't worry that that's negative, that's fine. It just means that b is -2, but our x value is positive, that's actually +1, and c in this case is 7. Super. Okay, let's just check those answers. X minus 2y is equal to 7, and 7x minus 3y is equal to 2. Absolutely super. So, we've got some questions here for you to have a little go at. So pause now, make it big. These are tricky, they do get harder towards the end, but this is a key skill that always comes up, so it's really worth doing. So let's make that big. Pause now and have a little go at that. So pause now and have a go at those questions. Okay, I'm going to pop the answers on, so mark these in green, mark them in green. Super, so thank you for watching this video on forming the equation of a line. Do make sure you're having a go at the questions, because remember, the only way to learn maths is to do it, and have a lovely day.